Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 19. The graph of a linear equation in two variables is a line. Imagine that. The graph of a linear equation is a line. Okay, this lesson has two different possible directions I can take it as an instructor. And one is to begin at the beginning here with exercise 1 and do a theorem. Read this theorem and then prove the theorem. This is more advanced, and since I don't teach the advanced math class at my school, I've decided to forego this option, and I'm going to just skip down to problem number 2. Example 2 is where we're going to begin this lesson. So I'm not going to go through that proof. If you were advanced, or if my students were advanced, I would probably do it, but that can wait. You can prove things more. It'll be easier for you to prove things at a later time, like maybe in 10th grade or whenever you take the true geometry course. Okay, so we're going to begin here at number 2. And it says use x equals 4 and x equals negative 4 to find two solutions to the equation x plus 2y equals 6. It says to plot the solutions as points on the coordinate plane and connect the points to make the line. So I brought in a grid here. You'll need graph paper for this lesson. So I have x plus 2y equals 6, and it says use x equals 4. So I'm going to substitute in 4 and solve. So 4 plus 2y equals 6 because I substituted in x equals 4. And in order to solve that, I do SADMAP and I subtract 4 from both sides. And I get 2y equals 6 minus 4, which is 2. And if I divide by 2, then I get y equals 1. So my x was 4 and my y was 1. Okay, so now we're going to do that again. X plus 2y equals 6. This time I'm going to do negative 4 for x. So negative 4 plus 2y equals 6. Add 4 to both sides. And that's going to cancel, and we're going to get 2y equals 6 plus 4, which is 10. Divide both sides by 2, and I get y equals 5. So when I plugged in negative 4, I got y to equal 5. So if I plot the point 4, 1, I start at my origin. The 4 tells me to go right 4, and the positive 1 tells me to go up 1. So this is my first point, 4, 1. My second point, I'll do in green, means to go from the origin left 4, up 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. And there is my second point here. Now it says to graph a line, and I'm going to get my ruler, attending to SMP 6, which is attending to precision. Okay, put this right on that as close as possible, rotate it, and there is my line. And we should probably get in the habit of this. Whenever you draw a graph, you should label your equation with the original or standard form of the equation. So there it is, x plus 2y equals 6. Okay, so now it says to verify that they are solutions to the equation. We should really write this out. I will do it one time, but then I'm just going to do it in my head. I'm going to show you how to check. So this is x and this is y. So then when I plug that in, I should replace x with 4 plus 2 times my y, which is 1, and that should equal 6. So 4 plus 2 times 1 is 2 equals 6, and 4 plus 2 is 6. 6 equals 6. It checks. If I do the same over here, I'm just going to do this one quickly. Negative 4 will be x, and 5 will be my y. So 5 times 2 is 10. Negative 4 plus 2 is 6, so that will check as well. Negative 4 plus 10, I think I said 2. Negative 4 plus 10 equals 6, so that does check as well. Okay, part B says, when x, actually let me move my graph for a second. When x equals 1, what is the value of y? Does the solution appear to be a point on the line? Okay, does the solution appear to be on the line? When x equals 1, what is y? So let me put the grid back. And it says when x equals 1, what is y? So if I go over to 1, here's 1 on my x-axis. My point is right here, and it looks like it's 1, 2.5. It looks like when x equals 1, actually let me do it as an ordered pair. When x equals 1, y looks like 2.5. So it says, does the solution appear to be a point on the line? It does. And then how do I verify that? Well, I plug it into my equation. So if x is 1, I'd say 1 plus 2 times y, which is 2.5 or 5 halves, equals 6. 1 plus these 2's cancel and I get 5 equals 6. And sure enough, 6 equals 6. So it is a solution. So the point 2.5 or 2.5 is my y value and when x is 1. Okay. Now it says, when x equals -3, what is the value of y? Does the solution appear to be a point on the line? Okay, so now they're asking us when x equals -3, so that's going to be -3 plus 2y equals 6. Add 3 to both sides. And 2y equals 9. Divide by 2, and y equals 9 halves, which is 4 1/2. So if I go over to -3, -1, -2, -3, and I go up and put a dot on the line right there, that definitely is -3, up 1, 2, 3, 4 1/2, which is 9 halves. Okay, so does this solution appear to be on the line? Yes, it does. Okay, part D says, is the point 3, 2 on the line? Well, 3, 2 means to go over 1, 2, 3 and up 1, 2. So that is right here. That's the point 3, 2, and obviously it is not on the line. So why is that? Well, if I plugged my values in to this equation, when x is 3 and y is 2, it should equal 6 if it's going to land on that line. And 3 plus 4 does not equal 6 because 7 does not equal 6. So that point is not on our line. E says, is the point 3, 2 a solution to the linear equation x plus 2y equals 6? Well, I just plugged it in and checked, and the answer is no. It will not be a solution to a linear equation unless the point lands on the line. Okay? Number 3. Use x equals 4 and x equals 1 to find two solutions to this linear equation. So this is another example, just like the one that was just done. Okay, so it's just like this, just different values. So pause the video, see if you can do this, and then we'll come back and check. Okay, so here we go. I brought in a graph, a piece of graph paper, if you will, a grid, and we will do this. So use x equals 4 and x equals 1 to find two solutions to this equation. So I'm going to plug in 4 first. So 3 times 4 minus y equals 9. 12 minus y equals 9. Subtract 12. Subtract 12. Don't forget this negative sign. Negative y equals 9 minus 12, which is -3. If negative y equals -3, then multiply both sides by a -1, or divide both sides by -1, and y will equal a +3. So when x is 4, y is 3. So that's the point 4, 3. Now we're going to do x equals 1. 3 times 1 minus y equals 9. 3 minus y equals 9. Subtract 3, subtract 3. Don't forget your negative. Y equals 6. Multiply both sides by -1, and that'll give me y equals -6. So I have the point 1, -6. When I graph those, I'm going to graph the point 4, 3. 1, 2, 3, 4. 1, 2, 3 is right here. Then I'll graph the point 1 comma negative 6 in red. 1 to the right, down 1, 2, 3, 4, 5, 6 is right here. Get my ruler. Okay. And there's my line. B, when x equals 4.5, what's the value of y? So that means go over 1, 2, 3, 4.5. And I go up until I hit the line, and it looks like it is right here. So at 1, 2, 3, 4.5 up, that's going to be this point here, which is 1, 2, 3, 4, and 1/2. So when x equals 4.5, what is the value of y? It should be 4.5 as well, but I'm going to check it using the equation. 3 times 4.5, remember I'm just using this, and x is 4.5, minus y equals 9. 5 times 3 is 15, carry the 1, 4 times 3 is 12, plus 1 is 13.5 minus y equals 9. Subtract 13.5 from both sides. Okay, and I get negative y, don't forget that negative sign. And 9 minus 13.5 equals a negative 4.5. And multiply both sides by negative 1, and I get y equals 4.5. And so sure enough, y is 4.5. C, when x equals 1/2, what is the value of y? So I'm going to go over to 1/2, and I'm going to go all the way down until I hit the line, and it looks like negative 1, 2, 3, 4, 5, 6, 7.5. So I'm saying when x is 1/2, it looks like negative 7 and 1/2, but I'm going to use the graph, or the equation now, to check my graph. 3 times 1/2 minus y equals 9. 3/2 minus y equals 9. And let's change y to halves, because we're going to have to add or subtract a fraction. So it's going to be 18/2. So to get rid of this 3/2, I've got to subtract 3/2 from both sides. And I get negative y equals 18 minus 3 is 16/2. I'm sorry, 15. 18 minus 3, not 2, is 15/2. So therefore, if negative y equals 15/2, y equals negative 15/2, which is negative 7.5. Now these two things also said, does the solution appear to be on the line? And the answer is yes to both of those. There's the one from C, and this is the one from part B. Part D says, is point 24 on the line? So I'm going to go to the right 2, up 4. 1, 2, 1, 2, 3, 4, and put a dot right there. That is the point 2, 4, and obviously I am not on the line. And I'm going to check it algebraically. 3 times x minus y has to equal 9 if it's going to be on the line. 6 minus 4 equals 9, and 2 obviously does not equal 9. So if these are not equal, this point is not on the line. It does not satisfy the equation. E, is the point 24 a solution to the linear equation 3x minus y equals 9? Well, in all actuality, what I needed to do was put this down here. Is the point on the line? No. It is right here. The line is right here. And E actually proves it algebraically, so I just kind of did it before reading E. Okay? Number 4. Use x equals 3 and x equals negative 3 to find two solutions to this equation. Plot the solutions on the coordinate plane and connect the points to make a line. Identify two other points on the line with integer coordinates. Verify that they are solutions to the equation. So this one's a bit different, but see if you can do it. Okay, so I just copied this question down. It says use x equals, let me see if I copied the right one, x equals 3 and x equals -3 to find the equation of 2x plus 3y equals 12. Plot the solutions as a point on the coordinate plane and connect the points. So this is just the graphing part, and then we'll do A after. So I just copied this down and put it over this banner so we can work it in a clean piece of paper area. All right, so here's what we need to do. Plug in 3 and -3 into this equation and plot them on the coordinate plane. So the equation is 2 times x plus 3 times y equals 12. So I just plugged in, oh, I'm sorry. I plugged in x, the two x values. So I got to say plus 3y equals 12. Okay, so I'm substituting in for x. And I get 6 plus 3y equals 12. Subtract 6, subtract 6. 3y equals 6. Divide by 3, divide by 3, and y equals 2. So therefore I have the point x equals 3 and y equals 2. Okay, so I'm going to plot that point. Start at the origin, right 3, up 2, and there is my first point. I'm then going to do it again with -3. 2 times x plus 3y equals 12. -6 plus 3y equals 12. Add 6. Add 6. 3y equals 18. Divide by 3. Divide by 3. Y equals 6. X is -3. Y was 6. And there are my 2 points. Now I'm going to graph this one. -3 on the x-axis. Up 6 on the y. Okay, get my ruler. Okay, put that right here and rotate it. We need to make this very accurate because of what the next thing is asking. Okay, this is a little tricky. We got to get that right on here. Right there is good. Okay, so there's my graph of the line 2x plus 3y equals 12. And I'm not going to label it. This should be written next to it to tell the reader that's what the equation of that line is. And now we're going to do part A, which is right here. Identify 2 other points on the line with integer coordinates, meaning corners of the grid. So I'll do those in green. And I'm going to start at this blue point here. That is not on a corner. That's not on a corner. That looks like it is. Okay, but this one definitely looks like it is. So does this one here. So those will be the 2 I use. There's others there, but just this one looks like it's right at the corner of a grid, and this one looks like it's right at the corner of a grid. There's another one here. But you just want to choose corners because these will give you fraction answers, and fractions are not integers. So now it says to verify that these points are a solution. And this is the point 0, 1, 2, 3, 4. This is the point x equals 0, y equals 4. And this point down here is the point 1, 2, 3, 4, 5, 6, 7, 8, 9, -2. 9, -2. So now we're going to check those. So the first one I'll check was 0, 4. 2 times my x, which is 0, plus 3 times my y, which is 4, should equal 12. 2 times 0 is 0. 3 times 4 is 12. And obviously 12 plus 0 is 12, so 12 equals 12. That is a point on the graph. And then now if we check 9, -2, it's 2 times that 9, which is my x, plus 3 times negative 2, which is y, equals 12. 18 minus 6 equals 12. 18 minus 6 is 12. 12 equals 12. It checks. So this proves those two make this equation true. And when two values, x, y values, make an equation true, that means they are on the graph of the line. Okay, now we're answering some questions about that. It says when x equals 2, what is the value of y? Okay, must be the end of the period. Anyhow, sorry about that. When x equals 2, what's the value of y? So I'm going to go back up here. Okay, we're here. When x equals 2 is right here. The value of y is right here. And it looks like it's 2.5. But I'm not going to estimate that. It might be a little more. So I'm just going to plug in x equals 2 to the equation 2x plus 3y equals 12. So if I say 2x plus 3y equals 12, and substitute in this 2, I get 2 times 2 plus 3y equals 12. 4 plus 3y equals 12. Subtract 4, subtract 4. And I get 3y equals 8. Divide by 3, divide by 3. So y equals 8/3, which is the same as 2 2/3. So if I go back there, I was saying that it looks like 2.5, but maybe more. So 2.5. So you're estimating if you're looking at a graph and don't know it's going right through an corner, which makes it an integer. So fractions are estimated on coordinate planes, but calculating the actual value requires the equation. Now it says when x equals negative 2, what's the value of y? So now I'm going to use this equation again. 2 times x equals negative 2 plus 3y equals 12. Negative 4 plus 3y equals 12. Add 4, add 4. 3y equals 16. Divide by 3, and y equals 16/3. 3 goes into 16 5 times with a remainder of 1. So the answer is y equals 5 1/3. If I go back to my graph, and I plugged in that value, which was negative 2. So if I go left 2, I should go up 5 1/3. 1, 2, 3, 4, 5 1/3. Okay. B, is the point 8 negative 3 on the line? So I'll go back to my graph. Is the point 8, so this is 9 here, so this is 8, negative 1, negative 2, 8, negative 3 is here. So is the point 8 negative 3 on the line? And the answer is no. And is it a solution? Well, now we should know it's not a solution because it's not on the line. But when they say, is it a solution, it says, basically what it's saying is plug this in and see if it's true. So 2 times my x, which is 8, plus 3 times my y, which is negative 3, equals 12. 16 minus 9 equals 12. 16 minus 9 is 7, and 7 does not equal 12, so therefore it is not on the line. Okay, here's number 5. It says to use x equals 4 and x equals negative 4 to find two solutions to this equation. So, plugging in 4 for x, I get 4 minus 2y equals 8. Subtract 4, negative 2y equals 4. And remember, do not forget that negative there. Divide by negative 2, and y will equal 4 divided by negative 2, which is negative 2. That is the point 4 comma negative 2. Go over here, 1, 2, 3, 4, down 1, 2, and there is my point 4 negative 2. And then I will do it again with x equals negative 4. Negative 4 replaces x, minus 2y equals 8. Add 4, add 4. Negative 4 plus 4 is 0. 0 minus 2y is negative 2y. Again, do not forget that minus sign. 8 plus 4, 12. Divide by negative 2. And a positive divided by a negative is negative. And 12 divided by 2 is 6. Therefore, the point is negative 4 comma negative 6. So I start here and I go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, which is right here. Okay, brought in my ruler, draw your line, and there is the graph of the line y equals, or x minus 2y equals 8. So I'll label that right there. X minus 2y equals 8. Part C says, or I'm sorry, part B, when x equals 7, what is the value of y? Well, if I go over here, 1, 2, 3, 4, 5, 6, 7, right here is my point they're talking about. It looks like negative a half, but I don't want to say looks like. I want to make sure. So I'm going to do the equation, x minus 2y equals 8 with x equaling 7. 7 minus 2y equals 8. Subtract 7. Negative 2y equals 8 minus 7 is 1. Divide by negative 2, divide by negative 2, so therefore y equals negative 1/2 when x was 7. And sure enough, 7, negative 1/2. When x equals negative 3, what is the value of y? Well, if I go negative 1, 2, 3, and down here, it looks like a half. But let's make sure using our equation. X is now negative 3. X minus 2y equals 8. Add 3. Add 3. Negative 2y equals 11. Divide by negative 2. Y equals negative 5 1/2. So my point is negative 3 comma negative 5 1/2, or negative 11/2, either way. So now we're going to check. Negative 1, negative 2, negative 3. 1, 2, 3, 4, 5, and 1/2 is definitely there. Next question says, is the point negative 2, negative 3 on the line, left 2, down 1, 2, 3, and it's right there. Obviously not on the line, so no. Is it a solution? Definitely not. And we're going to prove that by extending the page. And we're going to plug this into this to see if it's true. So negative 2 for x minus 2 times y, which is negative 3, should equal 8. Negative 2, negative times negative is positive. 2 times 3 is 6 equals 8. 4 equals 8. No, it doesn't. And so therefore, it is not a solution. It is not on the line. Okay. These are the ones I just did on the last page, so I didn't have to go back and forth. So it says, based on your work in exercises 2 through 5, what conclusion can you draw about the points on the line and solutions to the linear equations? The solutions are on the line. Based on your work from exercises 2 through 5, will a point that is not a solution to a linear equation be a point on the graph of the linear equation? And the answer is no, comma, because the x and y values, the x and y values of a point not on a line will not make a linear equation a linear equation true. Okay, the linear equation will not be true. So when we check it, like we did back here, when it does not check, where was that? Right here. When that's not true, it is not going to land on the line. 8. Based on your work in exercises 2 through 5, what conclusions can you draw about the graph of a linear equation? Every point on the line is a solution to the equation. Okay. Okay, last page. We're on the home stretch. This is lesson or problem number 9, 10, and 11 have a little bit of a different concept here, but it's fairly simple. And what it is graphing equations using intercepts. So you need to keep in mind that if we have a y-intercept, then x equals 0. So if I have a line, and let me just draw a line here, and it doesn't matter what the slope is, let me just do this, okay, and if I have a y-intercept, right now my y-intercept is right here, it's like half, 1/2, but if I move this line around, did not mean to move my graph, if I move the line, I move the line around, so right now the y-intercept is the 0. Okay, so let me move this over here, and let me put my pointer here. So right there, the y-intercept is 0. Maybe that's not going to work either. There, that's better. Okay, so right now the y-intercept right there is 0. So if I wrote this point right here is the point 0, 0. Now if I move this line up to 1, now this is the point over 0 up 1. Okay, and so that's the point 0, 1 right here. So now if I move this line up to 3, okay, so now my y-intercept is right here. That is the point 0, 3. Well, if you notice, the y-intercept is the y value that the line crosses the axis, the y-axis, and the x value of every point is 0. So whenever the y-intercept, whenever the line crosses the y-axis, the x value is always 0. And now if I focus on the x-axis, and I move my line here, well, if you look right here, this is where I'm crossing the x-axis, and that is the point -1, -2, -3, -4, -5, -6, -7. This is the point -7, 0. And now if I move this line, and let's just say I move it to -1 right here, so now my y-intercept or x-intercept is right here, and that is the point -1, 0. And I'll do one more point. I'll move this over to, say, here. And so if I'm focusing on this point right here, that is the point 1, 2, 3, 4, 5, 6. That is the point 6, 0. So if you look at these, this point here, this point here, this point here, when I move that line, the x value changed, but the y value is always 0. So when we're talking about the x-intercept, then our y is always 0. So in order to graph a line, now let me get rid of all this explanation here. In order to graph a line using x-intercepts, all you have to do is make x 0. So the first one, I'll make x 0. And in the other equation, I'll make the y 0. So this is -3 plus 8 times y being 0 equals 24. So -3 times 0 is 0 plus 8y equals 24. That's just 8y equals 24. So all you can really do is eliminate this portion. You get 8y equals 24. Okay? And then I divide by 8, and I get y equals 3. So when x is 0, y is 3. So that is my y-intercept, 0, 3. Now if I do this one and make y 0, this is going to go away because 8 times 0 is 0, and I get negative 3x, I forgot my x right here, equals 24. Divide by negative 3, divide by negative 3, and I get x equals negative 8. So when x is negative 8, y was 0. So I go negative 8 on the x-axis. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8 is right here. So now that I have those 2 points, I can graph a line by simply bringing my ruler over to the x-intercept, turning it so it goes up to the y-intercept, and there is my line using the x and y intercepts. Okay, so let's try that again. So actually, you pause the video, try this on your own, come back and we'll check it. Okay, so here we go. So in the first example, I want to find the x-intercept. So I want y to equal 0. And then I want to find the y-intercept, so I'm going to let x equal 0. So those are the 2 things I'm going to do. So let this first one, I'm going to let y equal 0. So that's going to be x minus 6 times 0 equals 15. Or x minus nothing is 15, or x equals 15. So I get the point 15 comma 0. Okay. Now if I do this and let x equal 0, then I get 0 minus 6y equals 15. Well, that's negative 6y, so then when I divide by negative 6, I get y to equal, 3 will go into 15 5 times, 3 will go into 6 twice, and it is negative 1.5, or negative 2.5, negative 5 halves, when x is 0. Okay, so if I plot that, now they didn't come up with some very nice numbers here for us to graph this, because now I have a number 15 comma 0, so let's go in increments of 5 for this. So 15 comma 0 is 5, 10, 15 comma 0 would be here if I made these all 5s. Okay, because if I went out 15, I'd be way over here. And then 0, negative 2.5. Well, if this is 5, negative 2.5 is halfway, so this would be negative 5 right here. Okay, I put 15. Let's change that. That point right there, this line here is negative 5, and we have negative 2.5, which is halfway, so it's right there. So I bring my ruler down and rotate it so it goes through those 2 points. And I draw my line through the 2 points. Okay, so there you go. That one wasn't as nice because they used such a large number here and it was hard to graph. Okay, so let's do it one more time. If I'm looking for my x-intercept, let's do one at a time this time. I want y to equal 0. So when I'm going to finish and get an answer, my y is going to be 0. That's all this is. It's very simple. So I'm going to take my x-intercept as y is going to be 0, so I have 4x plus 3 times 0 equals 21. And eventually you're going to get the hang of this. You're just going to cover this piece up and say, oh, 4x equals 21. Okay, and then divide by 4 and we're done. And 5 times 4 is 20 with a remainder of 1, so that's 5 1/4. So I'm going to go over 1, 2, 3, 4, 5, and then a little bit more for my 5 1/4 is right there. And then I'm going to do it again for my y-intercept. And when I'm looking for the y-intercept, that means my x has to be 0. So I'm going to have 0 in my x point, and I have to find my y. So if x equals 0, I have 4 times 0 plus 3 times y equals 21. The 0 times 4 is 0, leaving me with 3y equals 21, and I divide by 3, and I get y to equal 7. So I put 7 there, and that looks like 0.7, so let me move that. Let's move it over so it doesn't look like a decimal. There we go, 0, 7. How's that? So then I graph that point over 0, up 1, 2, 3, 4, 5, 6, 7 is right here. And then I go get my ruler that I deleted, and now it's at the top. Oh, no, there's still one here, so I have 2 rulers. Okay. And I'm going to bring this down to 0. Rotate. and draw my line. And there is a line going through those 2 points. I'm off a little bit, but you get the idea. So there is the line of the equation 4x plus 3y equals 21. So graphing equations using intercepts, you just simply make one 0 and then make the other 0 and solve twice. Okay, so that is the end of lesson 19. Review this lesson summary and go do your problem set.